Hi, it's Seta here. Welcome you to the new tutorial series about water system in Unity. Due to the fact that the water system is quite extensive and detailed, the tutorial will be divided into several episodes. You might ask, why not one long tutorial? But personally, I believe that with such a complex system, after watching such a long tutorial, 70% of things I explain would be forgotten immediately. And in the case of short tutorials, you have time to test everything, understand and remember. Especially since I watch probably most tutorials on YouTube and none of them explain exactly what it used for what impact it has on scene and how to use it. That's why I will try to create a tutorial so that the water system no longer causes you any problems and so that you consciously know what a specific function is for and can use it. It's a bit like going back to school. Let me know what you think about it, and now let's get started. In this video I will be using Unity 6 and demo scene from River Auto Material 3 by Nature Manufacture. At the beginning, I want to point out that the Unity water system is unfortunately only available in this moment in HDRP. So, if your project is in URP, or you are looking for something to quick and easy add rivers and waterfalls, then River Auto Material will be perfect for you. And no, this is not an ad, just my personal opinion. But now let's move on to our water system. To add it to the scene, go to Edit, Project Settings, and first in the Graphic tab, find Frame Settings, Camera, Rendering, and check if water is enabled. Then go to Quality, HDRP, Water, and enable the water system. Here we can also set the resolution of our simulation. The higher it is, the more detailed the water, but at the cost of performance. Below we mark whether our water will support decals, how many of them, and their atlas size. Here we can also specify whether water should support excluder, which allow us, for example, to remove water from the inside of a boat. And below you can select that interaction script should run on GPU on CPU. If you don't know what to choose, then in your project water is mainly a visual effect with a small amount of script interaction, choose GPU. If manuscript will interact with water, choose CPU. And now let's go back to our scene. At this point, it's also worth adding water rendering to our global volume. To do this, go to your global volume or create a new one, and then choose Add Override, Lighting, Water Rendering, select All, and set the state to Enable. We will come back to the other options later. Now we can finally add our water to the scene. To do this, right-click in the hierarchy window, then go to Water, Surface, Ocean, Sea or Lake. Click on your ocean and raise it up a bit to adjust it to the terrain. If you now look at the inspector window, we have several tabs here. Let's start with General tab. First, we have the surface type, where you can choose whether we want oceans, river or pool. Each of these had its own settings, but I will choose Ocean because it includes all the settings. Next, we have Geometry type. If we choose Quad, we can manually adjust the size of the water in our scene by increasing or decreasing the scale. It is used when you need simple water that impact performance the least, because the number of vertices stay at the same regardless of size. You can see this by switching to Wireframe and scaling the object. The triangle stretches or shrink based on size. Another option is custom, where we can add a mesh and generate the shape of the water based on it. This is especially useful when creating irregular lakes or rivers. For this, we can use Pro Builder, available in the package manager. After installing it, choose Tools, Pro Builder, Editors, create Polyshape, and then create any shape by clicking on the scene. When you finish, disable Mesh Renderer, so the object is not visible in the scene, and also Mesh Collider if you don't want the player to walk on the water. Then go to the ocean, and in the Mesh Renderer tab, add your object. As you can see, the water takes the shape of your model. Of course, you can go back and edit it to better fit the terrain, or export it as a separate mesh, using Tools, Pro Builder, Export. Just remember that this object must stay in the scene, even if disabled, because the water uses it to get all position data. The next option in geometry type is instanced quads. At the first glance, it looks no different from regular quads. But when we switch to wireframe view, we will see it looks completely different, because here, vertex density is scaled based on the distance from the camera. The closer, the more vertices or wave we have, making water less angular. If we now go back to water rendering in the global volume, we can control triangle's density using the triangle size slider. The last option in geometry type is infinity, which is almost the same as instanced quads, but in this case, water is rendered all the way to the horizon, regardless of camera position. Next, in our options, we have the time multiplier, which controls the speed of the water simulation. This might be a little confusing because it doesn't only speed up water animation, it speeds up or slows down the entire simulation. So if you have shorelines waves or drifting object, there will be speed up or slow down too. The speed of the water animation itself is controlled by current speed in the simulation tab, but we will get there later. Next, we have script interaction. So if we want to use any script, such as a drifting object, this option must be enabled. Below, we can decide whether we want not just the main waves, but also small ripples to be considered in the scripts, which of course comes at the cost of extra CPU calculation and might affect performance. The final element is tessellation, which allows us to artificially add more geometry to the model and smooth out the edges. The easiest way to explain this is change geometry type to custom and change view to wireframe. As you can see, the mesh we created has only a few triangles, so the water simulation will be quite blocky. But we can artificially increase the number of triangles using tessellation. With the slider, we can set how many triangles we want to add to make our water smoother. With tessellation factor fade start, we can set the distance at which those extra triangles start disappearing to avoid overloading the system. And with tessellation factor fade range, we can set how far from the start point of extra triangles should completely vanish. If you made at this point, I think you now clearly understand why this tutorial will be split into several episodes. In 8 minutes, we really only managed to add the water and explain its general settings. But I hope now you know exactly what they are for and how to use them. And there is much more ahead of us in the next episode. So if you like the tutorial, leave the thumbs up so I know it is worth continuing this type of tutorials, and don't forget to subscribe the channel so you don't miss the future episodes. Of course, if you have any questions, feel free to write them in the comments. And until next time, see ya!